Hello everyone, I am going to explain question 10th of exercise 2.1 of class 12th. The question 10th is, if sine inverse x plus sine inverse y plus sine inverse z is equal to pi, then we have to prove x root 1 minus x square plus y root 1 minus y square plus z root 1 minus z square is equal to 2xyz. So here this result is given to us and we have to prove this. So in this question we'll start by some special substitutions. So you have to take care that when you will get this question and properly recognize this question and these substitutions also. Just make sure in your mind that when this question will come, only you are going to start by the same substitution unless it's going to be very complicated. That's why take care of this question. And in this question the main substitutions are, we'll assume the sine inverse x as capital A, and this sine inverse y as capital B, and this sine inverse z we'll assume as capital C. Now when this sign will go here, it will go with A, so we'll get here sine A is equal to x. In the same way we'll get here sine B is equal to y, and from this result we'll get sine C is equal to z. So that will give us the values of x, y, z, because we need here to substitute the values of x, y, z. That's why we calculated the values of x, y and z, that is in terms of sine A, sine B and sine C. Now we'll start by the given thing, that is sine inverse x plus sine inverse y plus sine inverse z is equal to pi is given to us, and we replace the substitutions. We assume this as A, this as B, this as C. From here I calculated A plus B because I thought we'll need it. In the same way we can need B plus C also, any two combinations we can need. So we will finally, when we need, we will use this from this equation. Now all these substitutions we'll do in the left hand side of our question. The left hand side is this. So instead of x, y and z, we will replace the value. X is sine A and y is sine B and z is sine C. After all the substitutions we achieve this step, so carefully observe this step. Now here this root 1 minus sine square A is the value of cos A, you might know it. We use this formula in 10th class also, that is sine square theta plus cos square theta equal to 1. From that I wrote here cos A. In the same way it will become cos B and it will become cos C. Now here this step is very crucial. This also we have to take care that after achieving this step we have to multiply and divide by 2. Why we had done this? Because students, we know that sine 2 theta formula is 2 sine theta cos theta. So we need 2. That's why here we don't have 2. So we multiplied and divided by 2 so that we can get 2 everywhere, and we can change this complete term as sine 2a and this complete term as sine 2b and this complete term as sine 2c. But I kept this as it is because I knew that further I have to open it. That's why I not changed this, only I changed it. Now here this came in the form of s plus s formula, that is s plus s is 2sc. So I used 2sc formula. So with the first term we have to use plus sign, and with the second ratio we have to use the minus sign. So these are the angles, 2a and 2b are the angles. So with the first term, that is first term is of sine. That's why with sine between the angles plus sign will come, and with cos between the angles minus sign will come, and this term I kept as it is. Now here you can see this 2 can come out as common and 2 will remove by 2. In the same way here also 2 we just take common first and then cancel it, so 2 will remove. Just observe this step carefully. The numerator 2 and denominator 2 cancel each other, and other things I kept as it is. Now finally here you just see this a plus b. A plus b we can bring from here. A plus b if we want, then what is going to be? C is a shift here, so we will get here pi minus c. So a plus b I replaced by pi minus c. A minus b I kept as it is, and in the same way, because we converted a and b in terms of c, that's why here also any one c we have to remove, because the c students here we have a minus b. So anyhow I also have to bring here a and b. That's why this cos c I replaced C I replaced from here. If I want C from here, this A plus B will go here and it will come as pi minus A plus B. So find means here you have to replace them. Then sin pi minus C formula is only sin C because it will move to the second quadrant, and in second quadrant sin is positive and pi is there, so you not have to change the trigonometric ratio, that is sin will become sin only, and this cos A minus B as it is, and here this again move to the second quadrant, and you know in second quadrant cos is negative, that's why minus cos A plus B. So this minus finally will come out, and here we got here minus, and now here you just observe, here we have 2 sin C because we got from here, and from starting onwards we had here 2 sin C, they are same in both the terms, so we'll take it common, and this 2 will cancel by 2 and sin C is remained. Now here you just see what is after taking common, what we remained with, cos A minus B, and here we are remained with, because this minus sign came out, so here we are remained with cos A minus B. So it came in the form of C minus C formula. So C minus C formula is minus 2 S S. So first with S we have to use plus sign in between the angles, and with second S we have to use minus sign between the angles. So these are our angles. So A minus B is first angle and A plus B is the second angle. So we have plus sign, so I put here plus sign, and with second we have minus sign, so minus sign change obviously. Then when you will solve this, B will cancel by B, and here you will get 2A, so that 2 and this 2 is cancelled. In the same way here you will get minus 2B, and that 2 and 2 cancel, so we got here like this result. This minus sign why we got here, because of the formula, and this minus sign we got from here, and sin minus theta is minus sin theta, so this minus sign will come here and minus will multiply by minus, and we will get here plus. So we'll arrange them, all are in multiply, so we can write it as 2 sin A, sin B and sin C. Now from equation 1 we'll see what are the values of sin A, sin B and sin C, that is x, y and z. So finally in the result, instead of sin A, sin B and sin C, from equation 1 we will replace their values, that is x, y, z, that is our right hand side. Hence this question is completed. Thank you.